Hello, my name is Mr. Bryce, and I'm with Susquehanna Valley High School in Conklin, New York. We are doing pages 13 and 14 right now of Unit 1, Exponent Properties. Okay, so this is just a review. Exponents, at their most basic, represent repeated multiplication. Okay, so we can now move these around so they can be easier. If you notice, there is no addition or subtraction sign. Wait a minute, there's subtraction sign. No, that isn't. That's -2. Okay, that's not a subtraction sign. So what you can do is it says for steps 1 through 3, write the real number property. What happened here? Looks like that some parentheses moved. So that's the associative. Now let me make sure the parentheses moved. It's -2 x to the 5th 4x squared. -2 x to the 5th 4x squared. Yes, I said everything in the same order. So that's the associative property because we just changed the grouping. We put parentheses around here. Now here, you notice the x to the 5th went there and 4 went there. So we commuted, or a commutative property of multiplication. Explain why the final exponent of the variable x is 7. Okay, so that's way down here. So here, it looks like that we just regrouped. We're going to multiply the -2 and the 4 together. So when we regroup, it's the associative property of multiplication. Now why we can do that, okay, and we get -8. Why is that a 7 is this next part. So the reason why that is a 7 is x to the 5th, 1, 2, 3, 4, 5, and then times x squared. It says right here, it's repeated multiplication. So repeated multiplication is just x to the 7th. We went over exercise 2A. I said that you didn't have to do all this work. You can just run right down to the punchline. We're combining like terms. There's no addition. This is just multiplication. So -2 times -6 is +12, and x times x to the 4th. Remember, you add exponents when you multiply common bases. Common bases, we add the exponents. So here, there's no addition or subtraction. That's 18/2, which is just 9. And x to the 4th times x to the 10th. Common base, we add the exponents. So that's just 9 x to the 14th. Here, some people are like, oh, why isn't that like x to the blah blah? I'm not going to tell you what the wrong answer is so you don't get it into your head, but it's 4x cubed times 4x cubed. This here tells you write down 4x cubed twice. So it is 16x to the 6th. If you have any questions on that, make sure you ask me in class tomorrow or during saber time. Remember, monomials are terms that have more than one variable, just as long as you can combine them with multiplication and division only. Multiplying monomials that contain more than one variable still just involves an application of the exponent law. It's just a repeated use of the associative commutative property. So let's find each of the following products which involve monomials, multiples, and multiple variables. Be careful. Okay, so here I'm going to combine the 4s and the 5s, so that's 20. 4 times 5 is 20. Now, x cubed times x is x to the 4th. Y squared times y to the 5th is y to the 7th. We're just adding the exponents. So be careful there, okay? Just be careful. We're combining the like terms. There's no addition or subtraction here. We're only using multiplication and division. So you just combine the like terms using multiplication or division. So here, when we multiply those two together, we get 8. When we multiply these x's together, we get x, add the exponents, x to the 9th, and y cubed times y to the 6th is y to the 9th. We don't have to combine anything else. That's just the combinations there. So you multiply the numerator and the numerator is 5, and the denominator times the denominator is 4. You could have 1.25. I don't mind. You can write that down. Now, x times x squared is x cubed, and y times y to the 5th is y to the 6th. Why is it y to the 6th? Remember, there's an invisible 1 there as an exponent when we don't write them down. So there it is, page 13. And since that did take 4 minutes, I'm going to stop right there, and we can do page 14 next.